Hello YouTube and thank you for watching. In my previous session, I was querying the Stack Overflow database, looking for users that have posted the most number of questions. The display showed the user ID, which is not human readable, so I wanted to get their display name by joining on the users table using the ID column, matching the owner user ID. Let's run this query. Query took about 1.4 seconds to complete, and now the report includes the actual display name, which is human readable. Let's go take a look at the execution plan. What we find is that in my previous session, I have added a covering index, and the query is utilizing that covering index. On the users table, however, it is doing a table access full, which means that it's reading the entire table going from left to right, top to bottom, which is not a very efficient way of searching for records. And table access full always indicates that an index is necessary to improve the query performance. Now, when you're dealing with a query that has joins, there's a method to dissect and identify the columns that will be used in the query. And I will show you that method here. So take that query, and what we're going to do is paste it. For the first table, posts, what we're going to do is remove all the columns that are not part of the post table. So let's go ahead and remove this. Let's go ahead and remove that. Let's go ahead and remove this. And essentially what you wind up is two columns. You have the post type ID and the owner user ID. Let's do the same. This time focusing on the users table. So we're going to remove all the elements that are not part of the users table, which are these. Which leaves us with the ID column and the display name column. In case you're wondering why this method is being used, this is a very simple example, so you can quickly eyeball and identify all the queries on a given table. In a real world, a query can run with dozens of lines and contain hundreds of columns, joining on 10 tables or more. With that kind of a complex query, it is impossible to eyeball and extract all the columns for a given table. So this is a method that can be applied equally to a simple join or to a complex join that contains n number of tables. So in my previous session, I have added a covering index on these two columns on the post table. And we'll do the same, adding a covering index on the users table, starting with the join column and adding the include column. So create index on the users table, starting with the join column and then adding the include column. Let's go and rerun the query. The query now runs 1.7 seconds, still display the same information. Let's see what happened with the execution plan. So here you can see that instead of the table access full, it is now using the covering index on the users table. I have captured the before and the after execution plan. So let's compare and see if query has improved. So before the covering index was created, it was doing a table access full with the estimated row and the estimated bytes and the CPU cost of 55K. After the covering index was created, query is now using the covering index. The rows and the bytes have remained unchanged. However, the cost of the CPU has gone down to 45K. So it is definitely an improvement as the query will run quicker with less resources. Hope you found this information useful. If you enjoyed the content, please hit the like button and subscribe. Thank you.